There's been a lot of action and interest in global warming for the last 15 or 20 years, believe it or not. I picked up on this about 15 years ago and have been putting out little impact articles at ICR for about 15 years. So I've got about 8 or 10 of them, the last 2 of which are in that little pamphlet on the back of the table there that you've probably seen. And it's a rather interesting issue. I just actually finished the last chapter on a book yesterday that I hope to get published this fall, also entitled Some Like It Hot. And we have, our country and the world basically have bought the idea that global warming has been caused by man's release of carbon dioxide by primarily the burning of fossil fuels, and that we've done irreparable damage to the earth. And if we don't stop releasing carbon dioxide, it's going to become chaos. I didn't know whether to believe that or not a number of years ago, although I was skeptical because I knew from my experience in atmospheric science that there's all kinds of cycles that go on in the atmosphere and weather as well as climate. And I suspected that it may have been a problem with the way in which the data were collected for estimating the estimate of temperature increase. I then also suspected that there was other problems. But about 4 years ago, I decided I need to really deal with this. And so I started looking at some data. And this brief report here gives you kind of an update or a summary of what I found. I visited the observatory in Mauna Loa on the big island of Hawaii I guess it's about 6, 7 years ago now. My son-in-law was in the Navy at the time. Maybe it's 10 years ago. Time flies. At any rate, he was in the Navy, and he invited me to come over and join his ship on the way back from a Westpac, Western Pacific cruise. He was on a missile cruiser, and they have what are called Tiger cruises. So one of the family members can go and join them in Hawaii and then come back to San Diego with them. So I did that, but I went over for a few days early to visit the big island of Hawaii to visit this laboratory, because this is where the observations of carbon dioxide have been taken since 1958. Dr. Roger Revelle at the University of California, San Diego, who was known as an outstanding scientist and had been involved in climate issues and oceanography. He was one of the founders of the University of California, San Diego, and was a very strong spokesman on climate issues, had set this lab up back in the mid-50s. He had recruited a new professor at the university by the name of Keeling, and charged him with the idea of setting up a carbon dioxide measuring laboratory with the idea that possibly this might lead to a major issue down the road, and sure enough it has. At any rate, the data has been collected from 1958 at this particular observatory, and I might tell you a couple of interesting events that occurred when I went to visit the lab. First of all, the mountain you see in the middle of the picture there is Mauna Kea on the other side of the island. Mauna Loa is actually behind where I took this picture, and that's the lab in front of us there. And in between the two is this big saddle, and it's full of lava, just you know, the kind of lava you have in Hawaii, very flat and moves across. And I called up the university and asked to talk to Dr. Keeling, and he wasn't available, but one of his graduate students referred me to the fact, well, if you want to get permission to go to the lab, you got to call the lab or the office over, the NOAA lab over in Hilo, Hawaii. So I did, and I got to talk with this guy for about 45 minutes, and we were about 30 minutes into the conversation before I realized he was one of the graduate students that was at Colorado State University where I went to school. We were not exactly buddies, but went to school together. So we kind of caught up on old times, and when I told him what I wanted, he immediately gave me permission to go up to the lab. But he says, now it's a little difficult finding it, and he gave me directions out to the middle of that saddle, and he says, now when you turn there, it's going to be like you're just driving across a big sheet of lava, but you got to look for a line in the lava. I said, a line in the lava? He says, yeah, the only way we can get people up there, I mean, you can't make a road in this stuff. It's too thick and you don't want to take the expense of making a concrete road or pave it. So what we did was we had some of the guys get in the back of a pickup truck with about 10 gallons of paint. And as they were heading up toward the lab, they just kind of poured out a stream of paint across the lava. So it's about 10 miles of following this little crooked paint line up to the lab. But we finally got up there, and that laboratory has been operating since 1958, and they observe all kinds of other things there besides carbon dioxide. But the reason it's at that lab, Dr. Revell and Dr. Keeling wanted to have a location that was separate from nearby sources of carbon dioxide. They wanted a measure of kind of the average concentration in the atmosphere. And so by putting it out in the middle of the Pacific Ocean, they basically got away from almost all sources of carbon dioxide, industrial, cars, and so on, except occasionally when a puff of carbon dioxide would come out of the local volcano. And they could separate that from the data by wind direction and so on. So this is the location where the data is taken from, and you've probably seen this curve. This is the carbon dioxide concentration from about 1958 up to about 2006 here, I believe this is. Starts over in the left side here. This is the concentration. Let me do it over here. He asked me to do it over here. This is the concentration of carbon dioxide in parts per million, starting at about 315 parts per million in 1958. And it's currently approaching, actually probably exceeded by now, 380 parts per million. So it's gone up about 20% in the last 50 years. Starting in 1958, 50 years ago would have been 2008, up to 2008. So that's a fairly significant increase, and that's actually the curve of that. And it's actually more than linear. It has a sort of a geometric, maybe a parabolic shape to it. So it's actually increasing with time, the rate of going up. But there's also another feature on that, and that's this little oscillation in here, which is quite intriguing. And this also intrigued Al Gore. And there's a kind of an interesting story here because Al Gore, about 30 years ago or so, was taking a course or so at Harvard, and Dr. Revell came and presented the class, and he gave some information about carbon dioxide increases, and he interpreted this graph. These little oscillations are annual oscillations, so that in the wintertime, when the ocean is relatively cold and the continents are cold, the vegetation has died back, there's more carbon dioxide released, so you get a high point there. And then in the summertime, when the phytoplankton and the various plant organisms in the ocean bloom, they absorb carbon dioxide out of the atmosphere. Same thing on the continents, they absorb carbon dioxide, and you get a minimum there. Well, the thing that intrigued Al Gore was that Dr. Revell said it's kind of like the Earth is breathing. And you can see where that led. Al Gore is almost a pantheist, and so he sees the Earth as kind of breathing in and out, and that's where he gets that from. Well, first of all, that data is real, and that was the first thing I had to come to grips with, that yes, carbon dioxide concentration has been increasing for the last 50 years or so. The next thing I wanted to look at was to see whether, in fact, the temperature and other various features had been changing during the same period of time, or maybe even longer. And I decided to select 3 different sources of data. One was sea surface temperature, another one was hurricane formation, and a third one was the ice sheets in the Arctic, whether they're melting or not. And to get the data, this data is available on the internet. NOAA and NASA provide surface observations, upper air observations, satellite observations, and they put it all on the internet, and you can access this yourself. The problem is you can get overwhelmed by it in a hurry. And unless you've got a lot of people working and a lot of computers, you can get overwhelmed in a hurry, and you have to take out bias and all kinds of things. So I couldn't do that, but I thought that if I could take samples of data from 3 kind of random sources and look at them, what would the trends be? And so the first thing I decided to look at was buoys that are stationed out in the ocean. This is an example of a buoy that's established by NOAA. This happens to be in the Gulf of Alaska, and it has a number of types of instrumentation on it for measuring wind and speed, temperature, humidity, rain, and also temperature down in the ocean and salinity as well, oceanographic type things. And they're located all over. Each one of these little squares is a buoy out in the Gulf of Alaska and up near the Bering Strait. And they're all over the world now. Over the last 30 to 40 years, they've been adding these things. There's probably thousands of them now by various countries. But not many of them have been out there very long. So I needed one that had a reasonably good long record. So I looked for one, which was, I said was the 4,601, I believe, which is, I can't quite read it. It's in here somewhere. Right there? Right there. There it is. Okay, I can't quite see that far. Well, I can see it on my screen here. At any rate, it's just off of Kodiak Island, just east and south of Kodiak Island. And the reason I selected that one is because it's one of about 3 or 4 that have a 30-year period of record or more. Plus, it's in an area which doesn't get iced over too badly. If you go up north of the Aleutian Peninsula here, this area out here gets a lot of ice on it in the wintertime, and the buoys lose a lot of data. I wanted a buoy that didn't have a lot of data loss. And you have to take that into account. You're always going to have some data loss. Well, here's the data from this particular buoy, and this happens to just be the sea surface temperature. That's what I was primarily interested in. And it ran from about 1976 or something and like that up to about 2005. The vertical scale here is the sea surface temperature in degrees centigrade. For those of you not still proficient with metric, 0 degrees centigrade is the same as 32 degrees Fahrenheit. So this is the freezing point. So you'll notice that all this data is above that, so you don't have to worry too much about sea ice. And it goes from 76 to 2006. This is the winter time. The temperatures being the coldest, and the peaks up here the hottest. There's a little bit of missing data in there, but not too bad. There's a little gap right there. But basically, you see that with the annual oscillation again, and it's quite wide, if you put in a least squares fit to that, you see that there is an increase of something on the order of 1.5 degrees or so during the last 30 years. So the sea surface temperature in the ocean south of Alaska has been warming. Well, that would be consistent with global warming, at least in the ocean. Well, I also looked at hurricanes, or actually tropical storms. This is an example of a hurricane actually on the east coast, southeast coast of the United States, Hurricane Floyd back in 1999. There are records of tropical storms and hurricanes coming into the southeastern coast of the United States all the way back to 1850, would you believe? And you can get these on the internet. And you can download them, you can find what their path was, how big they got, and all kinds of things. In the last 35 now, or almost 40 years now, we have satellite data, which is much more accurate, and you get the paths that are much more precise, and you have a lot of other information to go along with them. But I decided to look just simply at the hurricane frequency. That is the number of hurricanes, or in this case, tropical storms. A tropical storm is one that's 39 miles per hour or greater. A hurricane actually has to be 75 miles an hour or greater. So I was looking at tropical storms. And I go all the way back to 1850 from the data that's available to me, or was available to me. And you'll notice here that there is, again, an indication that the number of tropical storms has increased with time. Now, why would that be? If the ocean, the sea surface temperature of the ocean is increasing, it turns out that the evaporation of water out of the ocean is what provides the fuel for a hurricane. If you get water evaporating and it's gathered by a tropical depression or a hurricane, it draws it in and lifts it in the middle of the hurricane around the eye wall, condenses it back to liquid water as rain, and the heat, the latent heat, is released at that point, which provides more lift. So it actually grows on itself, and it's almost like a carburetor. The water vapor is the fuel for the hurricane. And when you have a higher temperature, in fact, you can see this on individual hurricanes. I've got cases where a hurricane moves across a region of the ocean that's warmer, and within a matter of hours, the thing grows in intensity and in size and wind speed. Well, that's what we find here, is that there's an indication that the average has gone from a little over 6 hurricanes per year to about, what, 13 or so in the last 150 years. But you notice there's a tremendous amount of variation. Here was a period in which it was above the least squares fit. Here it's below it. And there's periods of time when it was below it here. And in the last few years, it's been going up like crazy. So this was an indication that, yeah, there appears to be some issues with tropical storms, at least. Now, you may have heard that hurricanes, the intensity, other people have analyzed these, and some people have suggested hurricanes have actually gone down in frequency during certain periods. So you have to really define what you're talking about. This is simply for tropical storms. Okay, well, I also, as the third one, looked at sea ice in the Arctic. And here's an example of a change in sea ice from the year 2000, which was the purple line. That was the coverage that year, the maximum coverage as it melted back in the summertime. And then in the summer of 2006, the white area. So it's actually decreased in area in the summertime. In those 6 years, it's changed that much. Well, we also have data for satellite data for the last 30 years on the coverage of the Arctic ice sheet, ice shelf, actually it is, over the ocean. Here's the average extent or the area of the ice in the Arctic in millions of square kilometers from 1979 or so up to about 2006. And again, you can see the whole thing is trending to smaller amount of ice, both in the summer and in the winter, and on the least squares fit as well. And that's actually decreased on the order of 15% or so in the last 30 years. Well, that's consistent. If the sea surface temperature is warming, then you would have less ice in the summertime. So the conclusion I came from this, it appears that we do have an issue, that there is warming going on. Now, the next question was, is this due to carbon dioxide increase? In other words, are the two related? So I needed to go and look at the actual data. And let's see. Okay, here is a temperature graph that is what's called the hockey puck diagram. Well, it's not as colorful on the screen as it is on my computer. Well, at any rate, this is a hockey puck diagram that was developed by a couple of researchers about 8 years ago over the last 1,000 years. This is temperature in degrees Fahrenheit here, but it's a temperature change. The average that they estimated was about a 20-year period from about 1961 to about 1981, if I recall. So this temperature is the difference from that average, and it's showing that it was basically uniform, maybe slightly negative, from 1,000 years ago to about 1900 or so, and then started climbing rapidly. Now, you notice there's a little hiccup in here, which we want to talk about more in a moment. But that's called the hockey puck diagram, which has become very controversial because it was challenged by some other scientists who said that the technique, the statistical technique they used to develop that diagram was not legitimate. And that controversy has not really been fully resolved, but it was more or less adjudicated by a couple of the societies, and basically says, well, you haven't resolved all the issues, but we're gonna accept it anyway, which is not the way you do science, but that's what's happened. Now, that's in quite a bit of contrast to the type of diagram that I was trained on years ago, and most paleoclimatologists, who I consider myself to be now, a paleoclimatologist is one who studies old climates. It's just a fancy name for that. But this is the kind of diagram that most of us were familiar with over the same period, approximately from 1,000 years ago to present, that there was a period of time from about 1,000 to about 1,400 years AD in which the temperature was relatively warm. Now, the scale here is in degrees centigrade, and it's not change, it's actual temperature. But it was a period of relative warmth called the medieval optimum. And this was a period when the Vikings settled Greenland. There was not as much ice there, so because it was warm, they were able to go there and settle. But then suddenly, the climate changed around 1400 and headed into what's called the Little Ice Age in here. There's various parts to it, but the maximum, or I should say the minimum, or the coldest period was in this region right here, and then things started warming back up again into the present time. This happened to occur in a period in which the sunspot cycle had relatively few sunspots. It was called the Maunder minimum, and we'll see that in a moment, a bit of that diagram. But there seemed to be some association with this, and for a long time people thought, there has to be a connection between the number of sunspots and the climate, but they could not find any connection. I mean, I knew of a friend of mine who was, he spent his whole career trying to find a statistical connection between sunspots and precipitation and temperature, and he never could do it. And it wasn't until just recently that there was a hint, about 10 years ago, that there is a connection, but it's a very subtle connection. Well, I began to look a little bit more deeply, and here's a diagram that has become very well known by and presented by Al Gore in his book and in his movie, An Inconvenient Truth. And one of the, if you've seen the movie or looked in the book, you may remember him walking across a stage with this big graph displayed on the screen in gigantic scale, and him looking at this and saying, look, here's the carbon dioxide concentration going up and down, going up and down. Oh, by the way, I need to give you the scale here. This is age, this is time going from the past 600,000 years ago on the conventional time scale closer to the present. So the present is right here, so it's reversed the way you would normally think of it. And there's also temperature here. I've forgotten now what the temperature is based on. I think it's delta O 1816 from the ocean. And methane. And you'll notice that there's a lot of correlation between the two. And his conclusion is, obviously carbon dioxide is causing the temperature change, because whenever the carbon dioxide goes up, the temperature goes up. When the carbon dioxide is down, the temperature is down. There's no question about what that's true. I mean, that there is that correlation. But when you get to looking at a little bit more detail, that's not the whole story. Let's take, for example, and you can do this in a number of places along here, but let's take one example right here near the last so-called ice age, which, by the way, this is the ice age maximum when it got the coldest, and then it started warming up. Each one of these is an ice age according to the conventional view. If you look at that in detail, you see a very interesting thing happen, though, and this is slightly different data. It's not from that same graph, but it's similar. Here you have time marching from right to left, and it goes from 22,000 years ago, which would be right near the glacial maximum. It was closer to here, but it's in this area, down to about 10,000 years ago. Here's a methane plot and carbon dioxide and temperature in the Antarctic. And what you find, and you can do this on the Arctic or any other place, you find very similar features. As the temperature goes along, it starts to go up in temperature before the carbon dioxide starts to go up. You say the same thing. There's a peak here, flattens out. The carbon dioxide does it later. And on the conventional time frame, there's about an 800-year lag in that. Now, if carbon dioxide is causing the warming, it should happen first. But it appears that the temperature change is occurring, which is driving the carbon dioxide. Now, why would that be? Well, the most obvious explanation is that the ocean has hundreds of times more, maybe thousands of times more carbon dioxide in it than the atmosphere. And when you warm the ocean, just a small amount, the amount of carbon dioxide that is dissolved in ocean is dependent very strongly on temperature. And as you warm the ocean, it releases carbon dioxide. When you cool the ocean, it absorbs the carbon dioxide. Very much like a bottle of soda pop. You take a bottle of soda pop out of a cooler that is not cooling the pop very well. It's hot, and you open it, it fizzes all over the place. When it's cold, it doesn't fizz, or at least not nearly as much. So the ocean is very similar in that regard, it appears.
How did they know what this was 20,000 years
You mean the people who presented the graph?
Yeah, the data for the graph 20 past.
Oh, it's based on seafloor sediment data and a time frame derived from that. That's a whole other story. I'm not suggesting that time frame is correct. I'm just using their data. And whether you have a compressed time frame or an extended time frame, the relationship between when they go up and down is going to be the same. It's going to be a shorter lag, but it's the same type of relationship. The second thing that I want to point out, which really questions this whole concept of the carbon dioxide being the cause of global warming, is this particular graph. And I pointed it out earlier in the hockey puck diagram, but this is a smaller portion of it. We showed earlier that the temperature was basically rising from about 1850 after we came out of the medieval, the ice age, I'll get it right, the little ice age. But the assumption is that it should go continually upward. If you've got carbon dioxide increasing uniformly like we've shown for the last 50 years, if that's been going on, and that 50 years, it covers this period in here. It goes all the way back to somewhere in here. But if that whole thing has been increasing in carbon dioxide, there should not be a period of time where the temperature decreased. So what you're looking at, this is the temperature. This is the year from 1880 approximately. And you have the temperature going up to about 1940, and then it decreases to about 1970 and then starts going back up again. Now, most of you in this room are old enough to probably remember back in the 70s all the hysteria about the coming ice age. And that's based on this temperature diagram. It took several years for people to, maybe 10 years to really catch on. But about 1970, when this thing, before it really started going up again, we'd had a fairly sizable period there. It was from about 30 years where the temperature was going down. And everybody, particularly in the atmospheric science department where I was in graduate school, we're going into another ice age. We got to do something. In fact, they began to think about it. I had just gotten out of the Air Force, and the Air Force had plans if the thing didn't turn around. In fact, they were doing some preliminary experiments of taking C-141s and filling them with lamp black and spreading them over the ice in the Arctic up on Greenland, in order, the idea being to cause the surface to absorb more solar radiation to warm the surface and to melt the ice was the idea. And they were really getting into that. It was getting serious when finally they realized the temperature was starting to climb back up again. Well, now we've got the other problem. Everybody's concerned it's getting too hot, and we need to do something to bring on another ice age. Well, this is basically, it turns out, though, that that shouldn't be that way if carbon dioxide is the cause of the global warming. Maybe there's something else. And that's when I began exploring some other features. And about that time, I discovered a group that had reported on this, a fellow by the name of Svensmark from the Danish astronomical group in Denmark. And he had proposed a theory, which is the basis of this new theory of global warming, that the activity, the electromagnetic activity of the sun, when it changes the amount of heating that the Earth has. And it's not just due to sunspots. Sunspots turn out to be just one of the features of the sun that we can now measure easily with our satellite observations. When the sun is extremely active, it has a lot more sunspots. It has more solar flares. It has all kinds of solar wind putting out all kinds of cosmic particles, neutrons. In fact, I used to work in Colorado at the Climax Observatory, which was one of the solar observatories for the University of Colorado. And I remember working next to this machine. It was constantly going beep, 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 beep. It was counting neutrons. It's one of the main neutron counters in the world. Well, you can look at the data from that particular neutron counter. You can look at sunspots. You can look at solar flares. And it turns out that there is a connection between the amount of heating and the activity of the sun. When the sun is very active, it tends to envelop the whole Earth. And it prevents cosmic rays from coming into the atmosphere. And when the sun is not active, it compresses and the Earth is more, it can be exposed more to cosmic radiation. Well, it turns out that there's a secondary effect that Svensmark has proposed, and that is when the sun is active and it's enveloping the Earth, it prevents cosmic rays from coming in, coming through our atmosphere, forming more nuclei, which forms more low-level cloudiness, in which the sun can actually shine through and heat the Earth. That's different than what everybody had thought before. They thought when the sun was active, it would be by direct heating of the Earth. But it's modulated by the cloud cover, which in turn is controlled by the electromagnetic strength of the sun and how these cosmic rays can come in and affect and form clouds. So then when the sun is not active, the Earth is more accessible or more affected by the cosmic rays. Cosmic rays come in, form more nuclei and more cloud cover, which reflect the solar radiation from the sun back to space, causing cooling. So it's a kind of a double order effect, and it's very strong. One of the reasons why the original idea of the solar connection with sunspots was thrown out was that the direct effect was less than 1/10 of 1%. In other words, as you vary the amount of sunspot activity, the amount of direct solar radiation was only varying by it was less than 1/10 of 1%, which could not explain the change in climate. But this effect has up to a 5% change. So that could modulate the climate more effectively. Well, this is an example. This is a plot that I have my students. I teach a paleoclimatology class through ICR online. And I have my students plot all these sunspots as a function of time. If you go back to the left, back to about 1600, there is absolutely no sunspots. This is the number of sunspots as a function of time up to 2000. Back here around 1600, there was no sunspots for about 70 years. Okay, there has been all kinds of studies to see what the correlation between the cosmic ray intensity and the heating, and that turns out to be very nice. Whoops, There's been a number of things that have developed since I started doing these studies, but basically what's happening now is that the theory that Svensmark suggested has gotten the attention of the world community. For about 10 years, they rejected his whole idea. It was ignored. And he just kept at it, and he kept doing experiments and publishing these in Nature and Science and various places. And he's finally got the attention so that the scientific community is beginning to turn around on this concept. Basically, the scientific community was steamrollered by this whole thing. They basically accepted the idea from some advocates, which were more politically motivated than scientifically motivated, to accept this idea of global warming. And the scientific community, which generally by and large doesn't want to get involved in a controversy, they stayed out of it until it was too late. And this whole thing became highly political. With Svensmark's work and his theories, there's more and more articles coming out now saying, we think he's got something here. And so the scientific community is beginning to make noise. Much more of the scientific community is saying, wait a minute, we've got to rethink this thing. But the steamroller has been going on long enough now that it's going to be hard to stop that. So that the point coming up at the Copenhagen Convention is to review the Kyoto Protocol. And at this point, the United States is going to become one of the lead advocates for implementing caps on carbon dioxide concentration worldwide, and probably institute an international trade organization like what Al Gore has developed in this country. Now here's kind of an ironic thing. Stop to think about this. Al Gore was out waving the red flag for global warming, and then he established a carbon dioxide trade commission, and he is now a multimillionaire coming out of his trade organization for trading carbon dioxide credits. Well, here's my conclusions. Global warming is occurring, and it's probably been occurring for more than 50 years. I say here 50 years, but I think it's probably closer to 150 years. It may be only a short-term fluctuation. It's probably longer term. The evidence is still inconclusive that recent changes are caused by man. I would say that there's probably more and more evidence that man is not doing it. We contribute to it, a very small percentage probably, but not in a great way. We haven't found any natural causes for recent warming that have been fully confirmed, but we got some real strong suspicions that are developing. And that final one is a new theory by Svensmark, a new theory that galactic cosmic radiation modulated by solar activity affects low-level cloud cover, and global warming shows great promise. And that's what I reported on that little brochure in the back. I think I'll stop at that point and entertain some questions.
Thank you, Larry.
Oh, I should have said this, I'm sorry. There's implications for Christians. From Genesis 8:22, it says, while the earth remaineth, seed time and harvest, and cold and heat, and summer and winter, and day and night shall not cease. And in 2 Peter 3:10, it says, Lord, to come quickly, but the day of the Lord will come as a thief in the night. So some people have been concerned about this global warming as a precursor of Christ's return. I don't think so. I think this is a natural variation. When Christ comes back, we're going to have fire all over the place, but it's not going to be led by a gradual global warming.
Okay, thanks.
Yeah, I had a question. I saw actually on a DVD. It's called The Great Global Warming Swindle. Have you?
Yes. Mm-hmm.
And I wanted to ask your opinion on that documentary. It's about an hour in length, and I personally was blown away by it. I saw both An Inconvenient Truth and this film, and this film clearly, debunks most of what's in the first film.
Some of the things that I mentioned in here are based on that documentation that was in that video and actual publications. The people that are doing that was headed up by a gentleman by the name of Singer, who was at one time the chairman of the National Academy of Sciences in the United States. And he was one of those that has been tireless in trying to get the attention of the scientific community that they're going down the wrong path. So he was one of the primary scientists behind that video. I have to say that although it was pretty well done, it was almost like Inquirer magazine in the way in which they went about it. But they became desperate because they couldn't get anybody to listen to them. So they produced that video in a rather dramatic way, and it was done in England. But even so, it's still pretty well done. I've used it a number of times to get people's attention also. By the way, you can see that on YouTube even today. If you go onto YouTube and look under The Great Global Warming Swindle, they've got it in 9 parts on there. There's some very interesting history behind that. When they got it on YouTube, it kept getting kicked off all the time because the people who were opposed to it kept taking them to court and threatening them with all kinds of lawsuits, and they had to keep revising it to get it on there. And they couldn't put it all in one piece. They finally broke it up in pieces. So it's still available, but they had a terrible time just even getting the word out. Yes, sir.
I had a question about, the first we heard about global warming was the hydrofluorocarbons, Freon. Mm-hmm. But isn't that a heavier than air gas? How could that affect the outer atmosphere? What's the story of Freon and fluorocarbons?
Okay. Yeah, that one was an early issue, and the argument behind that was that Freon, the previous kind of Freon we had, was very destructive of ozone. You can actually do that, demonstrate that in the laboratory, that if you have ozone in the container and you release some Freon in there, it actually eats up the ozone. And it turns out that that was also observed in the atmosphere at high altitudes near the poles. It had to occur at the greatest rate at temperatures around minus 80 degrees in the presence of ice crystals. The ice crystals served as a, what do you call it in chemistry where it's not affected, but catalyst. The ice crystal surface functioned as a catalyst for that production. And so they were flying U-2 aircraft up in that and actually seeing when the Freon, which they could measure, came up against the ozone, it was actually eating it away. You could see it eating it away and disappearing. So early on, I accepted that as a legitimate concern, somewhat reluctantly, because there are other sources of way to get rid of ozone, like volcanoes and all kinds of other stuff. But it turns out that was a legitimate concern. It also causes global heating, some global warming, but that wasn't the main concern. It was the fact that the ozone was being eaten up, which allowed the ultraviolet radiation from space, instead of being absorbed up in that layer of ozone, to get down to the surface, which could affect microorganisms and cancer on the skin. So the suggestion was we needed to change the kind of ozone that we produce and replace all of our compressors, which was unfortunate because everybody had to change out all their equipment, plus the fact that new ozone is only about half as efficient as the old ozone. But in the long run, it was worth it. But the other thing that was crazy about that was that the theoretical argument was it would take about 50 years for the atmosphere to get rid of all the old ozone and stop eating up, the old freon, and stop eating up the ozone. Well, within a matter of 5 years, when they were in this 11-year sunspot cycle, when the ozone hole began to fill in, the advocates of new freon claimed credit for that, and they shouldn't have. And then about 11 years later, when it started opening back up again, they suddenly got very quiet, because that was a natural process that they were taking credit for. Well, it is slowly working, but it's going to take another 30 years or so to heal our atmosphere from that. But the ozone actually is one of the reasons why we have a stratosphere that's hotter than lower in the atmosphere. It absorbs the heat up there. When you take away the ozone up in the upper atmosphere, you don't get the heating up there like you should. If you have the ozone down near the ground, it will cause heating down near the ground. So it depends on where you have the ozone. So there's a connection, but it's a little complicated.
I actually have 3 questions, if I may. First one would be, some of the charts up there that you had temperature variations on the Earth going back to 1800 and 1000 AD.
Yes.
Now, what kind of records are there, and how would they know
Good question.
back in 1200 AD what the temperature was on the other side of the Earth?
We don't have any direct measurements beyond about 150 years ago. The longest actual temperature measurements about 150 years ago at one or two stations in England when they first invented the thermometer. That's what a paleoclimatologist does, though. They estimate the temperatures all the way back in those periods of time by finding biological or chemical or various other systems that are sensitive to temperature. And then you figure out what that sensitivity is today, and then by measuring the way in which those systems were reacted in the past, you estimate what the temperature had to be back at that time. So it's an extrapolation. So it has a lot of uncertainty with it, but you can reduce that uncertainty by dumping more data in it and analyzing it very carefully. So it is a technique of paleoclimatology.
So
It's not a direct measurement.
In essence, it's really an educated guess.
Yes, yeah.
Right.
I have to admit that.
Yeah. Next question I had was on Al Gore's little bit there. He talked about 600,000 years ago, and the other chart was 22,000 years ago. It seems like from our perspective, I'd just throw the whole thing out to begin with, because the whole assumption is wrong in the first
That's
place.
another really good question. What you have to understand is the raw data is good data, but we have to figure out how to put the proper time scale to it. See, that's one of the projects that I work on all the time. Ice cores, for example. We know that the ice formed, and it's still, much of it is still there in Greenland and in Antarctica. But if you assume that it only, say, accumulated an inch a year, you could go back 250,000 years or 300,000 years. But it's a uniformitarian assumption. The accumulation we have today has always been that way. Well, if the flood occurred, we know that that's not the case. So my way of adjusting this is to understand what the precipitation rate was likely after the flood using computer models, and those rates were on the order of tens of feet per year, not an inch or two per year. And so from the modeling I've been able to do, I've been able to show, and I haven't reported this at this conference, but been able to show that you could explain the formation of all the ice in Greenland or Antarctica in something on the order of 500 years. So you adjust your time scale based upon the precipitation that fell.
Or less than 500.
Yes, or less than 500.
Yeah, but it wouldn't be consistent, though. It wouldn't be a uniformitarian.
No, not at all. In fact, it fell off exponentially probably as the temperature of the ocean cooled off. The precipitation fell off dramatically also. Yeah.
And then my third question was, I noticed your data ended at 2006, and from
I haven't done anything since 2006 on that.
From what I've heard in the last couple of years, the temperatures have dropped more in the last 2 years than in the previous 20 years.
Yeah, it depends on,
total.
here's where you can get biases, and you have to be careful how you collect and analyze the data. I have not gone back and confirmed this, but it's my understanding also that in the North American continent, the average temperature has been decreasing since about 2000. Now, these were sea surface temperatures. I haven't looked at the continental temperatures, but and that would be consistent with the activity of the sun. It should be starting to cool, and there seems to be some initial evidence that it is beginning. That's all I can say at this point. That's something I need to do.
Is it not true that we've been getting a lot of data from the robots that we've landed on Mars that shows that global warming is happening there also?
Yeah, there was some data about 4 or 5 years ago that Mars has been warming.
Then we should get a treaty with the Martians to put catalytic converters on their
Well, it says
flying
it's a
saucers.
solar effect, right? It basically says it has something to do with the sun. Yeah, that's right. So that would be consistent.
I have a question. You know, a lot of the ideas about global warming come from the UN IPCC.
Yes.
There's also another set of climate scientists who have published a different report called the Non-Intergovernmental, the NIPCC.
Right.
And their conclusions is totally different from the IPCC.
The NIPCC, whatever it is, they basically run by the group by Dr. Singer. They published that
Right.
article. Yes.
So I just wondered what you think of that particular report.
I haven't read it in enough detail to confirm that everything they say is valid, but based on the other reports I've seen them do, I would guess it is. So, yeah, here's one of the problems with well, let me explain two things. First of all, the IPCC has built much of their projections on computer models. Now, since I'm a computer modeler, I have to walk carefully here, but I like computer models as a tool, but you never take the results of a computer model at face value. In other words, it's a good estimate, it's a good attempt, but you never quite believe it. They believed it, no matter what happens. And so they bought it hook, line, and sinker. That's the first thing that ran into a problem. The second thing is that there is some evidence when you look back at the multiple ice ages over 600,000 years and you look at the data, there appears at the beginning of each one of those surges, or what they call an ice age, there's a lot of fluctuations. It appears that, in their mind, the climate goes unstable. And it gets warm, cold, and then suddenly goes into an ice age. So what they're thinking, this is what really is behind this whole issue. They think that we're at that point where the climate is very unstable and it's going to go into this oscillations and then go into an ice age. They think the global warming we're experiencing is just a temporary stopgap thing, but it's going to go into an ice age. And they think that by releasing carbon dioxide and particulates and all the activity of man, what we're doing is aggravating that instability. We're tickling it and causing it to do it sooner. And so that's why they want us to go back to a pristine environment. That's what's behind their whole model.